Hey, good afternoon, everyone. Welcome to reInvent. Welcome to Las Vegas. I'm happy to see so many of you in the room today who want to hear about how infrastructure as code can be a vital component of your strategy for governance and security in the cloud. My name is Eric Beard. I'm a solutions architect with AWS. I'm joined today by Mac Merritt, who's also with AWS, and by Ishu Gupta with Capital One. I'm going to get things started today with an introduction, and then I'm going to turn things over to Mac, who's going to cover some of the specific tools we offer for infrastructure as code at AWS. And then Ishu's going to talk about how Capital One has used some of these tools on their DevOps modernization journey. So the first thing I want to do is get to know all of you a little bit and see what kind of different roles we have represented in the room. So who do we have here who's from like a platform team, a Cloud Center of Excellence, CCOE, infrastructure team? Good number of you here. How about developers? How many software engineers do we have in the room? A few hands there too. How about security folks? Now I know security folks like to be covert. You might not want to put your hands up, but we won't tell anybody, but some security folks in the room too, good. What about the business side? Do we have maybe sales, marketing, some executive leadership folks in the room? Maybe just a couple of hands, good. So we have a good representation of different roles and responsibilities in the room. And the point I want to make is that, all of you are stakeholders when it comes to compliance in the cloud. All of you have a part to play. And all of these roles that we just talked about have different challenges that they have to overcome. So the business is always looking for ways to lower costs. You want to be able to lower costs, so maybe you can pass those cost savings on to your customers or increase profits, maybe a little bit of both. And then your security teams obviously are obsessed with reducing risk and making things safer. You've got that central security team, which is important. They're responsible for that overall security posture for your company, but what you really want is to have a culture of security across the entire company. So like I said, all of these stakeholders, so everyone is keeping this in mind. And of course, you have developers who are under constant pressure to get more features out to market. You want to win new customers. You want to keep the customers that you have. And so what is one strategy that all of these groups can use to help them overcome these challenges? And that strategy is automation. So I'm going to take a little bit of a detour here into DevOps and delivery pipelines. I know we're here to talk about security and infrastructure as code, but automating delivery of software to the cloud is a very, very important part of compliance and security. And what we're going to do is since we're doing infrastructure as code, we're going to apply the same kind of techniques to delivering changes to our infrastructure that we do for other parts of our applications, our website or our APIs. We're going to do the same thing with our infrastructure changes. So we're going to start with the developer. And I count everybody as developers. You don't have to necessarily be an object-oriented software engineer. If you're writing infrastructure as code, you're a developer. And during the development phase, we really want to optimize this phase for speed. We want people to be as productive as they possibly can. And we want to make it easy for developers to do the right thing. We want them to be able to code with confidence and knowing that they're developing secure applications by default. So we've got a lot of security checks that we do. What we want to do is shift those left. It's a phrase you're going to hear a lot when it comes to compliance and security. We want to shift those checks left so the developers can check their code early and often, and you don't get any surprises later on in production. So our developer, they're going to work on infrastructure changes in their own local environment. They're going to maybe get a code review on that. They're going to check that into source control. And then we're going to move on to our middle stages, our build stages, and this is all automated. This is where we're going to be building our code, checking our dependencies, and this is where we're going to run those security scanners again. And those static scanners that we have, maybe we're using AWS CloudFormation Guard, maybe we're using Open Policy Agent with Rego, but you're checking the code that you're writing to make sure it's secure and compliant. And there shouldn't be any surprises here, because like I said, we've pushed those checks left, we've shifted those checks left to the developer, but we're going to trust but verify. We're going to have some guardrails in place. We'll have guardrails in place here. We'll have more guardrails in place in production to check these things as well. But we hope we have no surprises. The analogy I like to make is, there was one time many years ago where I'm driving on the highway at night. It's raining, and my car starts to hydroplane, and I smacked into the guardrail on the left side, the divider between the oncoming traffic, which was terrifying and awful, scraped up my car a little bit, but I didn't die, which was good. So, I never wanted to hit that thing, but I'm glad it was there. So we are going to have these guardrails in place, but we hope to never hit them. And that's what I talked about, making it easy for developers to do the right thing, so we don't ever actually hit those guardrails. So once we've built the application, we've run all these static checks, we're going to start delivering this code to production. We're going to do this, like I said, just like we do for runtime code. Application code, we're going to do the same thing for infrastructure. We're going to deliver it first to a shared development environment. And these, when I say environment, this is an AWS account. Usually these are one account per environment. So we'll start in a shared development environment, and this is an environment that's, all of your developers own this environment. They're administrators in this account. There's no production data in this account. You should always resist the temptation to ever copy production data to a development environment. For testing, you should always use synthetic data. So, we kind of expect things to fail here. We're integrating software together. We're making sure it works. Then if it all works, all our tests pass, we're going to move on to a staging environment. And this one is locked down. We don't have people logging into this. We're going to treat this like production. We're going to maybe run some more realistic load tests in this environment. And then if all that succeeds, we're going to go to production, and maybe we'll roll that out in waves. Maybe it goes to one region first, and then 2 regions. We're being very pessimistic. We're looking for any reason to fail, roll things back, start over, and then start the pipeline again. And the point of all this is we want to be able to move fast and stay secure. And that's why I took a little detour into DevOps here, is because adopting DevOps practices, modern DevOps practices, allows you to do that. You can help developers do the right thing. You can move really quickly, but you can also stay secure while you do it. At Amazon, this is how we develop software. We have thousands of autonomous dev teams who are constantly pushing code to production many times a day per team, which results in millions of deployments a year. And we're doing this in a way that's fast but also secure. When we adopted these, and this is going all the way back to turn of the century, maybe late 90s, early 2000s, we found that not only were we able to move faster and be more secure, but we also had less incidents. We had less failures when we were deploying our changes. So there's a lot of benefits to adopting a DevOps mentality, even for your infrastructure changes. So this gets us to infrastructure as code, which is really, really a vital component for all of this. A lot of us probably started our cloud journey in the same way. We log into the web console, we're clicking around, we're learning how things work, we're learning how AWS works, we're building applications, we're experimenting. And, many people still operate this way today. We call this ClickOps, to where basically all the changes you're making to your production environments are done by somebody logging into the console and clicking around. And I don't want to turn that into a dirty word. It's okay to operate like that up to a certain scale. So quick show of hands, how many people here have production systems that are still maintained by going into the console and doing things manually? Yeah, quite a few, and that's okay. Up to a certain scale, that works. The AWS console is great. It does a lot for you. It's really helpful. But once you get to a certain scale, a certain size, a certain level of complexity, that starts to get really fragile. You have these really complicated runbooks you have to follow, some detailed documentation for reproducing an environment, and it ends up being very time-consuming and very error-prone, which can lead to security issues. So it can be a heavy lift, right? Going from using this super convenient, easy console to doing everything to moving over to infrastructure as code. It is quite a learning curve. There's a lot that you have to learn here, but it's really worth it. If you want to adopt DevOps, DevSecOps, if you want to be secure by design, and I'm throwing out a lot of industry buzzwords right now that tend to get maybe a little bit overused and misinterpreted. But the heart of the matter when you talk about DevOps or DevSecOps is that what we're trying to do is we're trying to turn all of those activities into one activity. So we don't want 3 different teams treating that as 3 different things that are being done in different places and at different times. We want everyone to have that operations and security mindset as we're developing and delivering code. And once you've adopted infrastructure as code, you get some great benefits. The first one is you get to take advantage of developer tooling. So now like I mentioned before, you get to do code reviews. So you get more eyes on the infrastructure configuration to spot maybe places where you're not following best practices. And then we can start plugging in all these static scanners, like I mentioned. Maybe you're using CloudFormation Guard or Checkoff or OPA. And then you get version control. So you get a history of every change you've ever made. So if you push something out to production that causes alarms to go off, maybe causes an outage, you can always just go back to that last version, roll that back out, and you should be back in business. And the last one is IDE plugins. So now you get to use something like VS Code or JetBrains, and you get lots of nifty little tools inside the IDE that as you're developing, that can flag things and point out things you could be doing better. But I think the biggest benefit for adopting infrastructure as code is consistent deployments. You want to be able to stamp out exactly the same architecture across multiple environments reliably. And we're going to start, like I mentioned before, in that developer's local environment, in a sandbox account. And I always have to take a moment to, when I talk about sandbox environments, to get up on my soapbox a little bit and talk about sandboxes and multi-account architectures. We really recommend, as a best practice, that everyone who's interacting with AWS as a developer or an operator gets their own AWS accounts to use for testing and experimentation. At least one. Even better is just multiple accounts. Give people the ability to create accounts, to experiment in, to do all of their development and testing. I'll get a little bit of pushback on this idea from folks who say, oh, well, that's going to be really expensive to set that up. It's really complex. But I can tell you, I have worked with a lot of customers over the years who run into some pretty complex and expensive situations that really result from just trying to put too many developers and too many production applications into a single AWS account. And it always ends up, in the long run, being much more cost-effective and much more productive to adopt a multi-account strategy. And it's not just about productivity and cost. We're here to talk about security. It's also about security because, if you have a new developer or a new operator maybe they're just learning AWS, they're experimenting, if they get something wrong, it's better for them to be in an isolated environment where the blast radius of that change is much smaller. You really don't want people learning how to use AWS in a joint account, in a shared account, in a production account. Even if it's not a production account, if you have a lot of developers sharing a single development account and something goes wrong, suddenly nobody can work and productivity stops. So there's just a lot of benefits to that. So I'll get off the soapbox about that and move forward. So, once we've done that development and the developer's happy with what they have, now we're going to start that automated deployment pipeline that we talked about earlier. And then we're going to stamp out exactly the same infrastructure in our dev account, in our staging account, and in our production account. And of course, these templates can be parameterized, so you have small differences between accounts. Maybe in the dev account you're using the small, cheap EC2 instances. Maybe in the prod account you're using the big, expensive ones. But for the most part, you are getting an identical infrastructure stamped out. And so the foundational service that AWS offers to help you implement infrastructure as code is CloudFormation. And I'm sure that probably most of you in the room do know about CloudFormation already, but just in case there are a few folks here who are new to the concept, I'll spend a few minutes talking about CloudFormation and what it is. So CloudFormation, it's an AWS service. It is a server-side orchestration engine that allows you to write infrastructure configuration in either YAML or JSON. And we kind of encourage you to write YAML. It's much easier to read and write than JSON. I kind of consider JSON more for machines to read than YAML. You can use YAML or JSON. You write a template, and then you submit that to CloudFormation, and that becomes what's called a stack. And these stacks will have groups of related resources. You might have one stack that's a fleet of EC2 instances with a load balancer in front of it, and maybe it has your networking configuration too. You'll have another stack, maybe it's an S3 bucket and a CloudFront distribution for hosting a static website. Maybe you have another stack that has an API gateway and some data in a DynamoDB table to act as a web API. And so one of the really great things about CloudFormation is that it makes changes in an atomic way. So if you submit a number of configuration changes or new resources, it's going to create all of those successfully, or if anything goes wrong, it's going to roll you back all the way to where you were before to leave you in a consistent state. Because trying to undo, halfway completed deployments can get really complicated. So CloudFormation does all of that complex work of making changes in an atomic way. And I talked earlier about the fact that this can be a heavy lift. If you've been doing ClickOps and just using the console and just your runbooks and documentation for a long time, adopting IAC, it is a bit of a learning curve. It can be a little bit intimidating. So what we have is a new service that can really help. It's called IAC Generator. So what you can do is you can go into an account where you've already created resources, everything's running exactly the way you want it to, and you can use IAC Generator to scan your account, scan all of those resources, pick the resources you're interested in and any related resources, and then it will generate a CloudFormation template for you. And then with another few clicks, you can turn that into a managed stack. And you've basically adopted infrastructure as code in a way that's much easier to learn and much faster to get started. It's also just a good way to learn how to write CloudFormation templates. You can go into the console, create the resources you're interested in, scan the account, create the template, and then just kind of learn how those templates get structured. And the last thing I want to cover before I turn things over to Mac is the AWS Cloud Development Kit, the CDK. So this is an open source project. I think this is probably one of the better examples of an open source, successful open source project at Amazon. And so the CDK is built on top of CloudFormation, and it allows you to write your infrastructure as code in a higher level programming language. So if you're a team that prefers an object-oriented language, maybe it's TypeScript or Python or C#, you can write all of your code in one of those languages, and then the CDK will generate the CloudFormation templates for you. And CDK is, it's more than a code generator. It also handles asset deployments. It handles deployments. There's quite a bit more that it does just beyond code generation, but that is at the heart of it. It generates those CloudFormation templates for you. And CDK, as you'll hear later, as Ishu talks about how Capital One is using it, can be a great strategy for compliance and security and governance in the cloud, because CDK allows you to write reusable components called constructs. So one of the other really nice things about CDK is it allows you to adopt something called GitOps. Now, GitOps is a phrase that's often just used in the Kubernetes crowd, but we can use it here as well. And the idea is that you're never making any out-of-band changes to an application. Basically, every change that happens to a deployed cloud application happens through a change that happens through source control. You do code reviews, so you do all your automated testing, you go through those automated delivery pipelines we talked about earlier. And you never have a situation where somebody's logging into a production account to change a network setting or to change an environment variable. All that's in your CDK application. And these CDK apps allow you to specify not just your infrastructure, you can also put all the runtime code in there. Let's say that you have a website or a REST API. You can put all of the Lambda function code right there in the CDK app. You can also specify your entire delivery pipeline. We talked about that 3-stage delivery pipeline where we go from dev to stage to prod. You can write that all in this CDK app, and you can put all the configuration for each of those stages into the app as well. So you don't have this separate environment configuration. It's all in one place, so that every single change that happens to that entire environment, including your pipeline, dev, stage, prod, any change that happens to those environments is happening through a single CDK application. So at this point, I am going to turn it over to Mac, and he's going to go into some of the specific tools that we have to help with infrastructure as code, governance, and security. Go, Mac.
Thanks, Eric. We're going to spend the next few minutes taking a closer look at the various tools and features within AWS that make it possible to have this goal of maintaining the security and governance that you need without having to compromise developer productivity and speed. I'm a senior engineer working in the AWS IAC organization, and I'm excited to talk about a number of the features that we released recently that are relevant for this story. But I'm also coming at this from the perspective of an engineer who uses many of these tools every day. Every team that I work on in AWS relies on infrastructure as code to deploy our infrastructure, and these are the very tools that we use to be able to maintain security as our priority zero, while still being able to deliver results and move quickly. We're going to start where any good coding journey would start, at least so far, that writing the code itself. I'd like to get another quick sense of where everybody's coming from and your familiarity with some of these tools. So can I get a quick show of hands of how many people have used cfn-lint, the linter for CloudFormation YAML and JSON? A number of hands around the room, thank you. And what about CloudFormation Guard, a tool for writing policy enforcement rules on templates? Okay, only a few hands. And then for CDK users, cdk-nag, which is a tool for policy enforcement on CDK code. Okay, great, a few hands around the room. And then Amazon Q Developer, our generative AI tool for coding assistant. All right, a few hands around the room. So whether you raised your hand just now or not, I think the next few minutes can be really valuable, and this goes for all the tools, not just the authoring time ones, where we have a few specific examples of new features or ways that you might not have considered how they could be used. But if you didn't raise your hand just now, we're also keeping this at a high enough level that you can see whether any of these tools might be relevant for you to consider, depending on your specific application and needs. And the first one we'll get into is cfn-lint. So a linter is a traditional tool for being able to apply best practices and improve readability of code. But cfn-lint goes a step further than that. It uses the resource specification for every resource defined in CloudFormation, and it knows about the syntax and behavior of CloudFormation so that it can give you syntax highlighting, the ability to be able to see what might go wrong very quickly. And it also gives you best practices based on a deep understanding of the CloudFormation engine itself. These best practices can help with having a more reliable and more secure infrastructure and being able to catch those faster and improve your productivity and shift left as well. So in this specific example, we can see one of those ways that it knows how CloudFormation works and leverages that to our benefits, where it highlights on this resource, it's a KMS key, and it highlights that I haven't explicitly defined the deletion policy for this KMS key. When the deletion policy isn't explicitly defined in CloudFormation, if the resource was deleted from a template, that resource would also be deleted in AWS. And for a critical resource like a KMS key, this could cause an outage or a security problem. So it's highlighting that a best practice would be to explicitly define that and make it so that if a developer went in and accidentally copy-pasted too much code, it wouldn't result in an unforeseen outage. In this second example, cfn-lint is highlighting that there is an unnecessary depends on relationship in this template. And this may seem like just an ability to get a less verbose template or to improve the readability, but it's actually a bit more than that, where CloudFormation is a declarative language. It doesn't traditionally need you to define dependencies explicitly. It can find those in the template. And by removing this, you not only improve the readability, but you also allow to take advantage of performance optimizations, such as earlier this year, we launched a performance improvement in the way that dependencies are managed to help have higher concurrency. And we've heard testing of up to 40% or even more performance improvement by allowing CloudFormation to optimize the dependency relationships for you. But by explicitly specifying a depends on relationship here, CloudFormation won't perform that optimization and will instead rely on the dependency defined here. So in this case, cfn-lint not only could give you a best practice to improve the readability of your code, but could also save you a large amount of performance improvement in the deployment itself. While cfn-lint is helpful for our governance and compliance, it's probably more on the productivity and speed side of that equation, where CloudFormation Guard is built primarily with policy enforcement in mind. It's a tool that allows you to define arbitrary rules that you can apply to your template and be able to monitor or check for the specific best practices that you care about most. We're going to look at one specific example of a type of issue or compliance concern you might look for with Guard, but you could define rules to check for any number of other ones. And we're going to return to this as our example, going through a few of the features to have some continuity. So one of the powerful things about infrastructure as code is that you can define related resources together for an application. This means that an execution role for an application can be defined alongside the infrastructure for that application. But this also carries with it some risks because we need to be concerned about making sure that the policies in that application are appropriately scoped. So here I have resource star defined for the role that I specified in this application. And this means that this role can now stop any instance in my account. It's probably not necessary for the application I'm building here. I probably could have specified the resources to just be the EC2 instances that were created in this application. And it's probably a good idea to have a guard rule that checks this. So I was able to write a guard rule that checks for any resource star statement in a template. And when I run it, I can see that the guard rule failed, specifically which ones failed after that. And then down here, it highlights the specific rule that failed. And this may look a little bit difficult to parse here, the language being a little bit unfamiliar, but I've actually found the learning curve on Guard to be pretty fast and pleasantly surprised at how easy it was for me to get started with writing Guard rules for myself. And then down here, it specifically highlights where in the template we had this violation so developers can quickly fix the issues that occurred. Now, these tools are both great if you're writing YAML or JSON for CloudFormation, but what about for CDK users, for people who prefer to use a programming style interface for their infrastructure as code? And that's where cdk-nag comes in. So when you synthesize CDK with cdk-synth, it does result in a CloudFormation file that then gets deployed. And you could, in theory, run CloudFormation lint or CloudFormation guard on that produced YAML. But it'd be very difficult to troubleshoot anything that goes wrong, because the developer would be seeing errors on constructs and resources that don't exist in their CDK code. It's not exactly a one-to-one mapping, as you can have abstractions or L2 constructs and other higher level use cases in CDK. cdk-nag gives you a more native experience to be able to apply the rules that you care about within CDK itself. And it also comes bundled with a number of rules out of the box called cdk-nag packs. And in this case, I have enabled the AWS solutions check. There's a number of other ones, such as HIPAA and various other standards that you could choose to apply by just simply importing it and then on line 12 adding it. Now when I run cdk-synth, I'm able to evaluate this particular CDK stack. And for an example of the types of things that that solutions check might find, I have a S3 bucket defined here, and it seems pretty good. I have block public access enabled. But when I run cdk-synth, I'm able to see that this bucket doesn't have access logs enabled, which is a best practice to be able to have better audit history of who's access to the bucket. And it also doesn't have SSL required, which encryption policies are very important to ensuring resources are accessed in the way that we intend. The final tool I'm going to talk to you on the authoring side of things before we start deploying our template is Amazon Q Developer. And I personally find Q Developer to be incredibly helpful for improving my own productivity. Whenever I'm writing application code or infrastructure as code, I always have it up in my IDE, and I use it to help me with quickly switching between languages, to be able to understand code bases quickly and ask questions about them, and also to be able to automate some tedious coding tasks, writing methods that I know how to implement, but just I can write it very quickly. But more so and relevant to this discussion, it has a baked-in understanding of infrastructure as code, whether it be CDK and CloudFormation, and it has a best-in-class security and vulnerability scanner so that it can identify some of the same issues we've been talking to. In this case, it identifies that same SSL problem that we talked about before, but instead of just identifying it, it also gives me suggestions for how I could fix it. And this suggestion I could use to inspire how I'm going to go fix it myself. Or if I'm satisfied with the preview, I can just simply hit apply fix and it'll go in and update the code to be able to apply these security fixes, making the number of security problems that I might find easier for developers to fix, and again, working towards that ability to have security and speed at the same time. So now we have a CloudFormation template or an ISC template in general, and we need to get it deployed. We need to get the infrastructures actually out in the world. And this is where continuous integration and continuous deployment come in. But I often see some confusion around the relationship between infrastructure as code and CI/CD. And I like to think about it as two separate touch points between these two tools. So on the one hand, infrastructure as code can be used to configure and define a CI/CD pipeline. Every team that I work on at Amazon has their CI/CD pipelines defined in an infrastructure as code file. And this allows us to be able to have consistency and code reviews on the CI/CD itself, since those systems can get quite complex and they're very critical to ensure that both our infrastructure and our application logic is deployed safely in the way that we want. But once a CI/CD pipeline is configured, they can then be used to deploy the infrastructure itself using infrastructure as code. And this can allow us to take advantage of CI/CD's tools for safety and deployments such as rollbacks and monitoring and testing to ensure that our infrastructure is deployed with the same kinds of safety checks that we would expect for application code. The tool we would start with in AWS for CI/CD is AWS Code Pipelines. It's the high-level tool for configuring how we're going to do our CI/CD, and it has integrations with various other AWS tools to help us have CI/CD all the way from our source code through building that and testing it, staging it, monitoring what happens in the staging environment to be able to see if we need to roll back, and then finally moving on to production once we have confidence in the deployment. One of the specific integrations for code pipelines that I want to talk to you is AWS Code Build. Now, a IAC template doesn't have to be built in the traditional sense of compiled code where it's turned into an executable. But AWS Code Build still has a lot of value for infrastructure as code because you're able to apply various tests such as this software composition analysis to check for the things that you care about at a platform level. We could define a rule very similar to that guard rule we did earlier so that any code that's going through my CI/CD pipeline is not allowed to have a resource star in the IAM policy, for example. And these platform level checks in no ways has to conflict with developer-defined checks that are more application specific and can also be created and defined in your CI/CD pipeline. Now, the AWS Code Pipelines also integrates with a number of CloudFormation features to help with the deployment process. And these features within CloudFormation are nice because they can be integrated with the CI/CD, but they also protect infrastructure as code deployments even if they come outside of the realm of CI/CD. And when we're talking about security and governance with infrastructure as code, the first tool we would talk to is CloudFormation Hooks. Hooks is a policy enforcement mechanism within CloudFormation. And once you enable a hook in an account in AWS, every CloudFormation deployment has to apply that hook unless it's been specifically filtered out. We've launched a number of new features for hooks this year to help make it easier to be able to quickly get up and running with the security checks that you would like. For example, we have now a Lambda-backed custom hook that makes it faster to write customized logic for whatever check it is that you want to apply. And we also have two features that are highlighted here. One is when I had this same template that I used for the guard rule earlier, and I tried to deploy it into CloudFormation, I now have a hook enabled that uses that exact same guard rule. And this is really powerful because it allows me to have consistency between the authoring checks and the checks that are run in deployments so that our guardrails don't have to come into play if somebody is following best practice. If my authors are applying guard before they ship the code, then they won't have to worry about this hook happening in production, but the hook is still there as a backup mechanism. And you can also see, if you look closely at the events here, that there are no resources that failed in this deployment. What that means is that this check was applied at stack time before any resources were touched, which allows us to shift left and catch errors quicker, but it also gives us confidence that our stack is not going to end up in any unexpected states or have to go through a painful rollback process. Instead, it checks quickly and then fails fast so that we can continue. Shifting left from resource time to stack time is really valuable, but can we do even better? And can we do a proactive check before we actually touch the stack itself? And that's where a CloudFormation change set can come into play. Change sets is a proactive mechanism that is able to give you a preview of what changes are going to be deployed as part of a deployment. Change sets have been enhanced this year to be able to have property level resolution. So you don't just see which resources are going to be deployed, but now you can see exactly what properties are changing. And we've also added an integration with CloudFormation Hooks so that you don't have to manually check a change set to see whether the changes are in line with your expectation. Instead, you can define a hook to run as part of a change set that will fail the change set or make it not executable if it has any violations that are against the policies that you care about. Both hooks and change sets are really useful tools for checking a deployment itself. When you're moving from one template to another, one desired state to another. And this works really well when we're following the best practice of having all of our infrastructure managed through infrastructure as code. But sometimes infrastructure changes outside of an infrastructure as code setting, either through unintended changes or through necessary operational impact or other mechanisms. And drift detection is a way to be able to spot those changes, understand them, and deal with them. Drift detection checks the live state of the resource, compares it to my desired state in the template, and tells me if anything is incorrect or out of alignment between the two. I could run this as a regular job or as a custom integration with code pipelines to be able to ensure that my resources are always staying in the state that I expect and care about. In this example, I modified the settings for a DNS configuration in the real state of a resource and was able to run drift detection and see it just to give you a sense of what it would look like if you were inspecting a drift detection violation in the console, and gives you the side-by-side view to be able to see the properties in both states. And then you can decide if you want to update your template to reflect the live changes or if you want to update the live states of your resources to reflect the template. Now we're moving on from just a single deployment and starting to think about scaling out to an organization and what it looks like for infrastructure as code to go beyond the boundaries of one account into multiple accounts or an organization. And CloudFormation Stack Sets is a tool that allows you to have the power of CloudFormation deployed across an entire organization. This is useful for defining very nuanced landing zones or bootstrapping of specific accounts or applications that need to be running in every account. We've also seen a number of customers have success with large data-isolated single-tenant applications, where each of your customers need their data to be highly separated from every other customer. And the best practice would be to have every application instance running in its own AWS account to have true isolation and have the appropriate security posture that you want. But when the number of accounts and the number of application instances starts to grow into the thousands or tens of thousands, this can be really difficult with traditional tools. CloudFormation Stack Sets is designed for this kind of scale from the beginning. It has default limits of 100,000 stack instances per stack set. And it has native integrations with AWS organizations so that you can define your application once, and then whenever a new account is added to the organization, the application instance is immediately spun up for you. We're also constantly working to improve the ability to handle this kind of scale with stack sets. Last year, we launched an improvement to the way that concurrency is managed as a customer when configuring your stack set called soft concurrency mode. And we have some customers who have reported 95% performance improvement through adopting that feature. Additionally, we launched a sample template to the CloudFormation Open Repository that now, if you deploy that sample template, it'll centralize all of the logging for every issue that has happened during a deployment and allow you to debug and troubleshoot any issues of a deployment all from the management account without having to log into any of the individual target accounts or worry about the thousands of account logins during troubleshooting. The final tool that I'm going to talk to here is AWS Control Tower. And it's not a traditional IAC tool specifically, but it's a highly recommended best practice, and it allows us to have a number of the protections that we've talked about all consistently applied across my entire account. And in this example, I used AWS Control Tower to set up that resource star check in every account in my organization. Kind of bringing things full circle to show that we could have the same style of checks happen at author time, happen during the CI/CD process, built into CloudFormation so that any other checks get applied to it, and scaled out to the entire organization through Control Tower. Now, I recognize that that was a lot of tools to cover in a short time, and the specific ones are going to depend on the application that you have. But my hope is that it shows at a high level it is possible to have this goal, to be able to have security and developer productivity and speed at the same time. And again, the specific tools that you will be using will depend on your application, and hopefully this gives you a high-level sense of which ones you might want to explore. With that, I'm going to pass it over to Ishu to talk about their experience at Capital One with using infrastructure as code and being able to have this consistency and security.
Thank you, Eric. Hi. Yeah. Hey, great discussion so far, Eric and Mac. So what I'm going to talk about is our journey to IAC at Capital One. And what are the benefits and the points that we leverage from this journey. So a bit, I'm sure in this room, probably all of you have heard of Capital One. If some of you have not, a brief introduction. Capital One is one of the largest banks in the country. Capital One is known for its modern tech stack and modern tooling and innovative products. Capital One is also the first major bank to adopt public cloud as well. My role at Capital One is I'm the Director of Software Engineering, responsible for building CI/CD pipelines and the CI/CD platform. So before I go and talk about the journey in a bit more in detail, I want to just talk about a brief background of where we started our journey of DevOps. So back in the day, I'm sure some of you have an exposure or experience of the similar life cycle. There were teams which were responsible for a specific part of the pipelines, right? In short, you can call them as experts of specific tools and processes. So for example, in this picture, you can see we had architecture teams which were responsible for building the architecture, engineering teams writing the application code, security team building injecting the security best practices and quality and operations, so on and so forth. This model worked great, but most of the teams worked in silos, and kind of each of the practices was kind of a black box for the other team. So the challenge that it brought up for us was, if there was a production incident, operations team was often looking for which team to talk to resolve that production incident. So this model worked great back in the day, but once we adopted Agile and public cloud, we saw a need of a transformation to our journey. So we took the other route and gave the power to our application teams and said, hey, go and build your pipelines. That works best for your use case. But the challenge that it created was the teams were just writing their own pipelines for their own use cases, and most of the team were just rebuilding and reinventing the wheel over and over again, specific for their application. Some of the teams even hired DevOps engineers which were sitting with them just maintaining the pipelines, which was not what we were looking for. So we took a decision and said, hey, we are a large company. Instead of centralizing it immediately, let's go LOB by LOB. We took a decision of centralizing the pipelines and software delivery at the LOB level, and it paid dividends. It worked pretty well, where we standardized to a large extent. But the problem still stayed, right? The teams were still building softwares in the silos at the LOB level. We made another big step here, and we adopted building a CI/CD platform for the whole company. Now, we didn't want to repeat the problem of the earlier days where we had a central team managing everything, and we end up creating a black box for everyone. So this CI/CD platform that we built allowed the application team to focus on the application logic and the business problems, while we take over these the boilerplate code and the standards that were required as a banking organization. So we standardize the peer review checks, the OSS vulnerabilities, and deployment best practices, and so on and so forth behind the scenes for our developers, and made it much easier for them. So this model worked great as well, but like everything, word evolved, AWS keeps on pushing so many good services over days in, day out. We found, we realized there is an opportunity for us to rethink our strategy to see how we can address some of these challenges. We realized that our pipeline lacked composability. By that I mean, our pipeline followed a rigid patterns where our pipelines can only do certain tasks for which they are aligned. We also realized that as a CI/CD platform team, we became the bottleneck for the company, where if a team need a new feature, they come to us and say, hey, can you update your automation? And since our blast radius was, we took time to evaluate their changes, we took time to go through our backlog and roll it out slowly. It took from days to weeks at times. We also lacked the ability of holistic application deployment, where if you have 5 APIs, and they go in together, that's great. But if you have large architectures, a human has to get involved and orchestrate those deployments, which created the possibility of manual intervention, which could lead to production incident. Also, stateful infrastructure, things which are just given by infrastructure as code out of the box. But since we were writing our own automation, we were using a bunch of SDK calls, and we had to build the capabilities that are offered by stateful infrastructure by ourselves, right? And that model was also not very long-lasting. So we took a step back and said, hey, what is our long-term modernization strategy here for our pipelines? And we took 3 major pillars here. Number 1, we decoupled our compliance logic from our deployment logic. So over the years, since we built all these pipelines and deployment tools, we realized that our compliance was actually baked in our deployment logic. That made it very hard to govern and maintain the life cycle for it. So we ran a massive exercise where we scraped our compliance logic, documented it, created a life cycle for it, and created a central compliance platform where all these policies were hosted and applied. One of the examples that Mac was talking about, you can use cfn-guard, you can use one policy agent backed by Rego policies, and things of such nature. We also pivoted towards stateful and composable IAC deployments, and we chose CloudFormation, AWS CDK, and a few other infrastructure as code tools. So with this, we were able to get all the IAC benefits that I'm going to talk about in the upcoming slides for our developers. Now, the third thing, which is building a pattern catalog. What we didn't want to run into, as we took a major initiative from going from a centrally managed hard-coded pipelines, We provided a lot of flexibility with these IAC pipelines. We didn't want our developers to just start writing their CloudFormation CDK construct in their own world and end up reinventing the wheel again. So we created this exhaustive CDK construct library where we hosted all these best practice based architecture patterns. You can call them L4 as well. I'm going to talk about those in the upcoming slides as well. So at a high level, our CI/CD pipeline still looked the same, but we were able to extract a lot of benefits out of it. So for example, if you look at number one, scan IAC templates for compliance. Since we centralize our compliance platform, we were able to scan our CloudFormation templates much earlier in the stage of the pipeline. So imagine a world where you're trying to deploy something in production and you fail at production level, right? We were able to perform the similar checks right at the checkout phase, which saved hours and hours for our developer times. Also, since we're using CloudFormation, it was easier for us to scan that declarative syntax. The second part is we replace our custom-built SDK calls with declarative syntax. That also provided the great capabilities that Mac earlier talked about. For example, we were able to leverage stack sets. We were able to leverage chain sets, which gave us a heads up of the deployments. We were able to get the idempotent nature of CloudFormation. By that I mean, one of the cool features that CloudFormation offer, if you try to deploy your CloudFormation and it has created your infrastructure, and you redeploy that infrastructure, it will skip a major part of that deployment because if the infrastructure hasn't changed or your CloudFormation definition hasn't changed, it will skip and perform the parts which are different from the earlier definition. That we saw the opportunity around 40 to 50% improvement with that capability. So as I already talked about, we saw a reduction in RTE cost. We had a faster feedback loop, reduction time to market, and better usability and reliability. One thing I wanted to call out in the previous slide that I missed, since we centralize our OPA policies here, we also offered those policies through an API, and then we expose that API through plugins. So developers were able to adopt those plugins in on their local machines, in their VS Code or whatever IDE tool of their choice. And as they were writing their CloudFormation templates or CDK, they got those squiggly lines, warnings, and then failures and saying, hey, the piece that you're going to deploy, it's not going to work because I see your CloudFormation out of sync with your compliance policies. So that was a huge benefit that our developer got right at their machine before even checking their code into GitHub. Another piece that I want to call out that we realized as part of the benefits that we saw was a lot of things are generally improvement opportunities are pushed by AWS. So one of the piece that Mac called out, 40% improvement by CloudFormation in its events. We got that improvement out of the gate without doing any investment from our side because it was the improvement in the underlying engine. Now, as a central platform team, it will not be ideal for us, for our thousands of developers to start writing CloudFormation in their GitHub repositories, deploying the same architecture. It will not be the most ideal path for us to maintain, manage, push upgrades, and stop those developers if there is if you want to make a big upgrade across the company. AWS CDK gained popularity to solve that problem for us. CDK provides the right amount of abstraction where a developer can choose, like in this example, you can say a developer is able to deploy a Fargate service backed by an API with 4 to 5 lines of code. If they were to write a CloudFormation for it, it would have been probably in the excess of 800 lines or something. So as we maintain this CDK construct library, we were able to upgrade, push upgrades, add more constructs, and things of that nature. Now, online, you will see a lot of material that talks about the CDK and its benefits and how to implement it. One thing that I want to share with you all today, how we were able to do it at an enterprise scale, I'll just talk about that at a high level. So as a central platform which is responsible for managing the CI/CD pipelines and the best practices, we built a central AWS CDK library. We built L2.5 constructs, L3 construct, and L4 constructs, whichever worked for our best use case. So for example, if you want to deploy an API, which is generally the most common use case across the companies, we build a corresponding L4 constructs for it, right? We also ensured that we build a pipeline to our construct library so that we publish the construct built in multiple different languages. One of the big benefits of that was when we publish those constructs to our binary repository, developer can import them in their own GitHub repository in the language of their choice, making their experience much seamless and simpler. Another piece that we did with our CDK library was building our regression suite. We wanted to ensure that the library that we are the constructs that we are publishing are compliant out of the box. So we built a very exhaustive regression suite that took our construct through the same compliance engine that we built earlier to ensure that the constructs which are published and when the user end up using them, they don't run into the compliance problem. That gravitated the developer community within a company to use our CDK library. The third piece that was very instrumental for us to use our own stack synthesizer, because the stacks, we wanted to ensure that the CDK constructs that we are building or the CDK deployment strategy that we have is compliant within our company, and we use our specific IAM roles, which are more compliant to our use case. The second piece to this puzzle, which I think was very, very innovative by our team, was building discoverability for these IAC resources. So IAC provides a lot of flexibility to you all, right? Developer can now choose the service they want to deploy and how they want to deploy it. Although it can create a problem for a central team where nobody knows who's using what kind of resource, right? So the way we solved it is we instrumented our pipelines, we instrumented our construct, and we published all that data as part of our CI/CD pipeline and streamed to a central database and dashboarded that data. Now the results were amazing. As you can see, like these are sample dashboards here. One of the examples you can see, the developers can see that somebody is using a CloudWatch, code deploy and Lambda together. There are 11 repositories using that. Now, as a central platform team, I know that I can make an investment on that pattern because that seems to be a popular pattern, and I can go and start maintaining that construct more closely. The benefit for the community there would be all these dashboards were hyperlinked to their repositories. So if, as a developer, I want a reference implementation, I can go and click those dashboards and get to the repositories of those constructs usage and follow the similar best practice for me. So this was pretty cool use of instrumentation for these libraries. The third, last and not the least, was building a community of practice. So if you're using CDK or IAC in your company, it is easier said than done, for sure. It's very easy to use IAC, but it is definitely a skill to use it at scale across the company wide. I would highly recommend to build a thriving community of developers. We ensured that we use inner sourcing to our CDK library to ensure all the usage to our central platform is contributed by our developers. They're not waiting on us to build features for them. Instead, we reward them as they send their pull requests, and we cater to them in the right amount of time. We also built community of practice where engineers came, showcased their implementation, talked about how they're using these IAC practice, and the third most important thing was we built hands-on training exercise specific to our company, and we partnered with AWS TAMS in our organization. There are a lot of online training material available, but you all know nothing can replace a hands-on all-day session. So we made an effort to build a specific catalog for us, a workshop for us, and we partnered with AWS where AWS TAMS talked about how to use it the right way, and we talked about how to use our library and how to stop reinventing the wheel and just lean on the central one. With that, I will hand it over to Eric.
All right. Thank you, Ishu. That's always super interesting for me to get an insider look at how a large enterprise like Capital One is building and delivering software. I'll wrap this up first just by saying thank you for attending, everyone. I hope all of you have learned at least a little bit about how AWS services like CloudFormation and the Cloud Development Kit can help you develop strategies and strong processes around governance and security and delivering infrastructure changes. So please, everyone, don't forget to fill out the session survey and let us know how we did. And we will, the three of us will hang out a little bit up here as long as we can, and maybe outside as well if you have any questions for us. So thanks again for coming.